Today we are going to see the transient response analysis of a circuit, and this is very important while designing a power supply for the circuit. When a circuit is switched from one state to another, the current in the circuit will change, and this is the pictorial circuit diagram of a lamp connected to a battery through a switch. When the switch is in off position, the lamp doesn't glow. When it is in on position, the lamp will glow, and the current from the battery through the switch and it goes to the lamp. As we know, the lamp is an incandescent lamp made up of coiled coil of tungsten filament, which is a pure resistor, and the current in the circuit changes from 0 to the load value. The current characteristics of current depends upon the elements present in the circuit. That is the passive elements present in the circuit. The passive elements may be resistor, inductor, or a capacitor. And this is the response of a first order system, that is one energy storing element present in the circuit. Either it may be a inductor or a capacitor. Right? It has a two states. The one is a transient state and second one is the steady state. In the transient state, it starts from off position to on position. It transitions from off position to on position. When it attains a 95% of output, then it is called as a steady state. After the transient state, the steady state will take over when t tends to infinity. For example, if we have to connect a charger to your mobile phone, as we know, the mobile battery having 3.7 volt and it is connected to a 5 volt power supply. When it is switched on, the voltage starts from 0 to 95% of 5 volt, that is 4.75 volt. It is connected to the battery, and this period is the transient period, and this value should be less than in terms of microseconds. After that, it is steady state value, which is t tends to infinity. And this is the response of second order system. It may have either two capacitor or an inductor and capacitor, or it may have a two inductor, that is an energy storing element which having two only. Let us assume that if you are connecting a 230 volt supply to an electrical equipment, it starts from 0 to 230 and it has settled down in some other value. And the transient state, which is the 95% of output attained, the desired output, which is the transient state. After that, it should be a steady state. In general, the standard 5% error is allowable as per the Indian. So for a 230 volt supply, the 5% error is nearly 10 volt, and the value changes from 220 to 240, that is prescribed in the any electrical equipments. And for the transient analysis, we are going to discuss about the natural response, forced response, and transient response of oral RC and oral C circuit. And then using Laplace transformation, we have to discuss about the sinusoidal excitation of DC and AC values. In the natural response, it is a system response to the initial condition, with all external forces are set to 0, that is no active elements present in the circuit. The response produced by the energy storing element present in the circuit, that is the inductor and capacitor, which produces the response. And for the forced response, it has an voltage or current source present or both present in the circuit with 0 initial conditions. Let us see the transient response for a pure resistor. For an example, if we connect a resistor to a supply through a switch, and we have to draw the current waveform. In x-axis we have the time scale, and in the y-axis we have the current scale. when you switch on, when the switch is closed at t equal to 0, the current drastically increases because it is a pure resistor. It starts from 0 to the desired output and it settles down as a steady state value. And this value may depends upon the load value, that is a load current. And this period is called transient period, that is the 95% of output after it is in the steady state period. Now we are going to see the online simulation tool. The online circuit simulator, we have a battery, switch and a lamp. You have to connect the source to the switch and switch to the lamp and lamp to the battery. And in order to find the response of the circuit, I connect one oscilloscope to the circuit, the positive terminal to the battery lamp and the negative terminal to the battery or the circuit. When we switch on for a pure resistor, the response may change. Did you see the response? It started from 0 to the corresponding 1.5 volt to the lamp, and it is a transient period and it is a steady state period. Now coming back to the circuit, the transient response of an inductor. The inductor is connected to a battery through a switch and it produces the response which is in increasing function because the inductor which opposes a change in flux or a change in current. It value which is it have to magnetize itself and then it produces a magnetic pulse. So there will be a lagging, that's why it is an increasing function. And for the capacitor, disconnected, the capacitor is connected to a source through a switch and it is a previously charged. When the switch is closed, the current will have to discharge that value, that is it have a decaying function. And in transient circuits, we have an integro differential equation as the series RLC circuit. The voltage rise which is equal to voltage drop across resistor, inductor and capacitor. We have a integro differential equation. In order to solve this circuit, solve this equation is very difficult. So to solve this in a simple manner, you have to go for a transformation, which is the transformation of complicated equation into algebraic equation is needed. So we go for a Laplace transform. The advantages of Laplace transform is to transform the exponential trigonometric function into simple algebraic equation, and it transform differential integration into multiplication and division, and this is just easier to handle or to solve the problem, and it doesn't need any arbitrary constants, but in general equation, voltage equation, we have to specify the previously charged value of a capacitor or a inductor, and it comes out with a complete solution by using this Laplace transformation. And at last, it gives a response of the system for any input. It may be a step input or ramp input or a parabolic input or an impulse input. It gives the response of a system. And these are the table to solve the how to convert the normal time domain into f of s, the Laplace domain. And in the later videos, we are going to discuss about the transient response of RL and RLC circuit. Here is a single energy storing element, which is the first order system. Here the RLC, which having two energy storage elements, is a second order system. Thank you for watching the video.